Actually, that's stupid. Everybody, observe the stupidity of that question. It says at t equal to 3. Wasn't I given? Didn't I give you at t equal to 3? It's like, oh, I didn't mean to actually give t equal to 3. Okay, Dom, can you please remind me to send this document to everyone? Okay, that was a pretty idiotic. Okay. Huh?
Should do like an intro to your YouTube videos.
An intro to the YouTube videos. Shh. Guys, we'll just pick it up from 12. Can you please copy down 12? Nobody speaks. In the other class, Mr. Arnold answered this correctly. So it says find the instant of time t when the object is only moving in the horizontal direction. It's kind of guiding you towards it. So help me. If the object is only moving in the horizontal direction, go on, Mr. Banchan. Okay, so careful. Take the ball and run. So you're almost there. Ms. Eunice, you're right though. So you're not moving the y direction. Therefore, thank you, y dash should be 0. There's nothing to memorize. So the y component of the velocity should be 0. You're not moving. So y dash. And don't we already have the y dash function? You just plug it in. Okay. Or set it equal to 0. Blah, blah, blah. Okay. Draw a line, please. That finishes the second kind of problem I could ask you. So I'm letting you know on the test I gave you an x dash y dash function. Okay. On the test, that was the kind of problem you had. Okay. Copy down number 3, please. Right on the topic, it's called parametric functions. Okay, we will not do the entire problem. In the other class, even when we began, most of the kids said, yeah, I know exactly how this works. So it says 4t cubed minus 9t squared plus 6t. Copy down A, or if you're lazy, just say particle at rest and underline the phrase at rest. That's the operative phrase, or the most important part of the phrase. Okay, nobody speaks. I'll open it up to the class. So the particle is at rest. And the question is, at what time will the particle be at rest? Anybody? This is what I should do. So the question is, what math or what algebra will we do? Ms. Eunice? So she says the velocity should be 0. Therefore, okay, the key word I was looking for is the plurals. She said, take the derivative and set them. Do you understand why them as opposed to set it? We have two components. So make a note to yourself, please. So I'm going to set x dash of t equal to 0. That's the x component of the velocity function. Y dash of t equal to 0. Okay, now play along. We're not doing it. I don't have time to do it. Now assume for a second you solve that. You get t equal to, say, monkey, donkey, orangutan. And you set this equal to 0. You get monkey, panther, donkey. What would your final answer be? Monkey and donkey, the ones that match up. Is that clear? So it is tempting for you to choose all of them. That will be a choice on the AP exam. It's a favorite on the AP exam. But if it is absolutely at rest, then the x component and the y component should be 0 of the velocity function. Is that clear? And let's do B, and I'll even discuss the most common error students make on the test. It says on your notebooks, write down point x comma y. So these are the two important components. And then you can say that, if you're lazy. So it says find the point on the graph where the graph had a vertical tangent. Nobody speaks. Think about the formula and then you have vertical tangent. I'll guide you. So if you have a vertical tangent, what must be true? Mrs. Sarkozy?
Y dash of t over x dash of t equals 0.
Thank you.
Does not exist.
Does not exist. All right. So you say a slope, we're talking a vertical line. So dy over dx, I like that he's actually teaching us. Because some people already figured out the final thing, but he's actually teaching us. So in other words, y dash of t over x dash of t. If it's vertical, the slope does not exist. Therefore, Mr. Sarkozy,
X dash of t equals 0.
thank you. So that's what I'm focused on. Is that clear? Let's actually do it. Okay. If you haven't taken it down, copy down x of t. If you have not taken it down, we'll actually do it. So you have x of t equals 2t cubed minus 9t squared plus 12t. Next step. Equals, color, look down.
60,
Continue.
18,
Plus. Can we factor out a 6? Magic X. Negative 1, negative 2. So t equal to 1 and 2. Stop. Now observe the most common error students make on the chapter test. And they stopped. Read the question though. What is the question asking for? Find the points. And some of you lost points because you are not answering the question. So make a note please. We need x of 1, comma, y of 1. And likewise, x of 2 and y of 2. You need to answer the question. Most kids thought, oh, so find the t values. That wasn't the question. It said find the points. So plug it back in and you're good to go. But that's not profound. It's just answering the question. Finding t does not answer the question. Okay, now we're doing even a more challenging problem. Draw a line. So it says, oh, okay. All right, I think I should just ask Marzu. Copy down x of t, y of t. It's like I don't expect anybody else to recall that formula. This is the second derivative formula, comes in multiple choice. Guys, I'm giving you study time. Try not to pick at your notes when you're doing your homework. Do your utmost. If you're doing homework, we're doing problem 4. If you're doing your homework every single day, Ariana, you can easily get a 4 or 5. You're smart enough to get a 4 or 5. But because of your work habits, it's like, man, okay, be up to date. We have about 30 plus days till the AP exam. So this is the time to, not to fool around. This is not the time to fool around. Okay. As a general thing, please understand this. You guys are calculus BC students. If you get a 3 or lower, you'll have to retake the class in college. This is free here. Please understand. If you got a 4 or 5, the UCs will give you college credit. It's okay. But understand the consequences of not passing the class or not passing the exam. You'll have to retake the class. Like, man, I should have just gotten it over with. All right. Should we first find the first derivative? Let's do that. So dy over dx equals over dt over dx over dt. Okay, let's take the derivative directly. Look down. So the numerator, careful. Do not mix up x and y. So the numerator is 2t all over minus 2. Okay, now let's go over the second derivative formula. Let's see who remembers. So it's d squared y over dx squared. It is smart to call this guy y dash. Okay, that's y dash. That's just from the first semester. Okay, Ms. Mazut, what's the formula? Okay, over dt here, all over dx over dt. Keep in mind, that's the guy. So we, in simple language, we take the derivative of that y dash function with respect to dt. In other words, just take the derivative. Divide by dx over dt. Wait a second. Do we not already have dx over dt from before? Was that not dx over dt? Just be alive. Just be aware of that. Okay. So how do I take that derivative? Quotient rule. You don't have an option. Look down now. So 60 minus 2 square. Top left. Parentheses. Times. Minus. Parentheses. 2t plus 4 times. All over 60 minus 2. Okay, now I'm going to do a little bit of mental math. What's 60 times 2 here? 12t. What's 6 times 2 here? Will the negative sign subtract them? Okay, what's negative 2 times 2 here? Negative 4. What's 6 times 4 here? But there's a negative sign. So what's negative 4? Take away 24. So negative 28 over 60 minus 2 squared divided by 60 minus 2. How do we divide fractions? Do that. Tell me your absolute final answer. Look down. Simplify the fraction, the rational expression. Tell me the absolute final answer. Okay, check your answer against the board after you finish. Now, look at the question, please. Do they give us a point to plug in? This is at equal to -1. Okay. I hope you can plug in a value without making mistakes. Okay, let's go to problem 5, please. Problem 5. In your notebooks, only write dx over dt is that, and then dy over dt not given. Okay, in your notebook, just write that. It says the y component dy over dt is not explicitly given. That's AP language. I just took this from an AP exam question. Or if you're lazy, just say dy over dt not given. And then can you write this in notation yourselves if learning happened? Okay, write that in notation yourselves. In terms of notation, I know the top half of the class is perfectly fine. It is smart to be aware of this. So dy over dt notation is also y dash of t. Is that clear? Dx over dt notation is also x dash of t. They're not different ideas. They're just notational issues. All right. Okay, I want to move on. So they're giving us x of 1 and y of 1. Is that clear? So part A. So write down this information. At t equal to 1, dy over dt equals -5. The value of dy over dt is -5. The question now says, write the equation of the tangent line. In your notebooks, if you're lazy, you just say equation of tangent line. Okay, let me break down the problem for you. What are the two things I need to write the equation of a line? Point slope. So do I basically need x of 1 and y of 1? Wait a second, isn't that given to us? If you're alive, wasn't that the point given? Exactly. Was it like, what, 2, -3 or something? Okay, so that's nothing but 2, -3. What is the other thing I need to write the equation of a line? Slope. So this is point. I'm showing work. Slope. Ms. Noro, what's the slope formula? So dy over dt over dx over dt, correct? And do we know dy over dt at 1? Yeah, over there, it's given. You just have to be alive. -5. How do I find dx over dt at t equal to 1? What do I just do? Because haven't they given us dx over dt? Just be alive. Can we plug into x dash, so is that x dash of 1? And then can we find the equation? So y minus y1 equals x times x minus x. So they're giving you tools. Use them. Okay. Write on B. Say speed at equal to 1. Okay, try not to be, write on the speed formula. Mr. Ben-Sufyan.
Radical x dash of t squared plus y dash of t squared. dt.
Thank you. Oh, no dt.
Oh, wait.
It's only if we have integrals. That's distance. If it's just radical, there's no dt involved. Okay, now stop. Look at the board. So do I basically need Ben-Sufyan? More specifically at 1. So x dash of 1, right? Equal to 1. So x dash of 1 squared. You could have just written this. Y dash of 1 squared. Correct? Wait a second. Would we not have got this from the previous part when we found x dash of 1? Isn't that given to be -5? Can we square that and type this into your calculator? Okay. So that's from A. We would know that from A. X dash of 1. When we were finding the equation of line. Okay. Stupidly simple. Alright, C. Now C is trickier. Nobody speaks. Copy down C, please. Copy down that entire thing. Now I'm letting you know the homework mimics this. If you're comfortable in class, get practice at home and you'll be fine. It'll solidify the concept. But if you say, no, I'm not going to practice, then it's complete. Please understand, memory, the human memory is exponential decay. You keep forgetting stuff. When you do homework, it basically goes back up. Then don't practice, it goes down. Homework, it's very well studied in psychology. Anyway. So it says find the acceleration at t equal to 3. Okay, let's see where we're going. So I need a of 3. Is that basically x double dash of 3? and y double dash of 3. Which one can we find very quickly?
X.
Because don't we know x dash of 3? Or x dash of t rather? Okay, so this one, I know x dash of t. So I can find that guy very quickly. Alright? Now keep in mind, I don't have y dash at all. It says clearly y dash is not given. Nobody speaks. Do some writing. They're giving you some piece of information. Take the ball and run, and then 30 seconds later, raise your hand and say, okay, this is how we do it. Observe that information. If you say, I'm going to figure it out, but you're not even going to look there, like, why have they given that? Okay, look down, do some math, and then say, okay, I figured out how to do the problem. Raise your hand when you figure it out. And let me tell you, because I have a very good memory, the last time Ms. Romero figured it out, because I have a good memory. Mr. Ordaz.
Would you take that and multiply it by dx, because that's dy over dx?
Thank you. Or more specifically, he's telling us that will be the end result. Isn't the slope, basically they're giving us dy over dx, which is y dash of t, over x dash of t, which is given to be 2t minus 3. I'm showing you every step, like, okay, if you do this, the answer shows up. Now, do I not know x dash of 3? So can I just cross multiply both sides by that? That's why he said just multiply. Therefore, y dash of t, I do know x dash of t times 2t minus 3. He's just using his common sense. They're giving us a piece of information. Well, maybe write a formula. So look at the board, please. And remember, I would know the exact function. Can I then find y double dash? Your calculator is doing numerical derivative. The calculator is handling all the crazy bit. And then from here, you can do y double dash of 3. You know that. Just be alive. Just be alive. Like, why do they give us that? Well, maybe write a formula. Cross multiply. Solve the equation. And your calculator is then doing the hard bits. Okay. Good news, bad news, depending on your perspective. So we have done a complete and thorough review of parametric and vector functions. Now comes to the last concept, which is polar functions. I do expect you to have forgotten this stuff, so pay closer attention. This was the one that was weirder. Please understand, the questions we have done are dumbass easy. They're very easy problems. So we're now doing polar functions areas, okay? In your notebook, just copy down that guy. Now, I do expect you to have forgotten this, and I'm okay with that. But if you do your homework, you'll be fine. It says the domain is 0 to pi, where r is measured in centimeters. Oh, that's what the kids were talking about. Mr. Arnold said centimeters over radian. I was like, where did he get that from? Now, I'm reading the question. The question gave you that. He said, so it should be centimeter over radian. I was like, oh, he's a smart fellow. He figured out centimeters. Okay, maybe. So, Mr. Arnold just, I don't want to say fell in my esteem. He rose in my esteem, but he just fell back to where he was. So, there's no special applause that he requires, that he deserves. Okay. All right. If you'll sketch that figure roughly. Okay, sketch that figure roughly. Now, I have moved down. Can one of you call out what r of theta is, or r? Like that? Okay. So, this is the graph they're giving us. All right. Now, see if this comes back. In general, when they give a graph, it is smart to figure out where you start, like 0, 90. See if that comes back very quickly. I want to get a feel for how this graph goes. So if I plug in 0, that collapses. What's cause of 0? 1. Oh, is that 1? So that is 0. And then we plug in pi over 2. Yeah. 2 times 0. Okay, let's plug in pi over 2. What's 2 times pi over 2? What's cos of pi? Negative 1. And what's pi over 2, which is 1.5? What? I hope you remember that. What's 1.5 minus 1? Is that about 0.5 there? Okay, so this is pi over 2. I'm confirming, like there's no hanky-panky going on. And then finally pi. Pi is about 3.143. What's cos of 2 pi? 3 plus 1? So that's 4.15. So we're just here. Okay, so pi. Is that clear? Alright, now we're doing A. Now I'm letting you know on the test, almost nobody got this right. In a class of 45, maybe 5 kids got it perfectly right. So copy down A and then we'll talk about it. So it says that theta equal to pi over 6. Find dr over d theta and interpret your result. It is the interpretation that many kids screwed up on. They did not do it carefully because they did not do the math completely. So do I just need to find dr over d theta? Is that r? Can we just take the derivative? So dr over d theta. Don't get alarmed by the theta. Theta is like an x. So what is the derivative of theta? 1 plus or 1 minus sine 2 theta. Is that clear? And should I plug in the pi over 6? I'm going to plug in, I'm using calculus notation at pi over 6. So it's 2 times pi over 6, which is pi over 3. Pi over 3, I'm doing the trick for you. Sine of pi over 3, sine of 60 is radical 3 over 2. Long story short, that's what it is. And that number is negative. Okay. Now, put your pencils down so we can talk about it. Now, if you do not know anything else, okay, so radical 3, I'm just letting you know, it's like 1.7 roughly. So it's roughly negative 0.7. If you did not know anything else, this is what you would write. Don't write. I'm telling you, this is not a complete answer. Indicates that at theta equal to, this first semester interpretation, indicates that at theta equals pi over 6, let's see who remembers. What's the definition of R again? It is not radius. What does R stand for? Distance from the origin. So what's the board, please? Indicates that at theta equal to pi over 6, the distance of the origin, distance of the curve, or the point on the curve from the origin is decreasing at the rate of 0.7. That is not correct. Miss Human?
We have to find R and compare.
I love this girl. And again, for those of you not aware, she's an art major. Okay, I'm just emphasizing that. Like once she gets a concept, she does not leave. It's like a vice-like girl. Okay, so she says, no, I also need to know what R of pi over 6 is. Is that a positive number or a negative number? Let's go with that. So R of pi over 6 is pi over 6 plus, that's cos of 2 times pi over 6, which is pi over 3. Cos pi over 3 is 1/2. And that is obviously a R. So R is positive and R dash is negative. So for those of you who remember, if you have opposite signs, the distance of the origin is increasing or decreasing? It's decreasing. Okay, now let's write a perfect interpretation. So let me call it out. Indicates that at theta equals pi over 6, since R of pi over 6, R parentheses pi over 6, and R dash of pi over 6 have opposite signs, the distance of the curve from the origin, repeat, the distance of the curve from the origin is decreasing at the rate of 0.7 centimeters per radian. So in the other class we did this. Some kid said, Rama, can we do this? Look at the board. Because you may say, Rama, I don't know that's 0.7. How do I know that? Because radical V is 1.732. So some kid said, Mr. Arnold, he said, can I do absolute value? Okay. Write that. You can write is decreasing at the rate of absolute value 1 minus radical V. I don't know whether it's positive or negative. I know it's negative, but I don't know by how much. How many of you understand what he's talking about? Okay. Again, I do not know what that quantity really is. I do know it's a negative number. If I'm saying decreasing, should I put absolute value? Again, for those who say, I still don't know what you're talking about. If you say decreasing, I can't have a negative sign, can I? You understand that? So I'm forcibly making that a positive number. Okay, yes?
Is it just decreasing at the rate of 0.7 centimeters?
Yes, because when we write decreasing, we use the positive number, right? We don't say decreasing at the rate of negative 0.7. That's the point I'm trying to make. Okay? Let's do another question. Shh. Copy down B, please. Copy down B. It says find dx over d theta. Remember we are doing polar functions. So I need x first. For those of you not aware. If I don't have x, I can't take the derivative. So who remembers what the x formula was? R cos theta. So x of theta. And just don't get alarmed by that notation. It just means x is a function of theta. So was it R theta plus cos 2 theta? Times cos 2 theta. Okay. And then when I find x dash, how do I find x dash again? Product rule. Okay, just make a note. I'm not doing it. So we'll use the product rule. Okay. And assume the answer is monkey. Okay. Or it'll be a negative number. So negative monkey. So read the question. And it says, interpret your result again. So who remembers, if you understood the previous one? Yes, Ms. Marzu. Thank you. We should find also x of pi over 6. I want to know if that guy is a negative number or positive number. So you will also make a note, please. You will find x dash at pi over 6 and then x of pi over 6. Just like the first semester. Now assume for a second, make that negative, just for the sake of it. Assume for a second. Oh! It's almost like, for those of you remember, look at me please. I'm tying up concepts. You'll say, oh my god, I totally get this now. I've been struggling with this. Is that basically position? Yes. Is that basically velocity? From first semester, if position, here's a simple example. You're on the left. Okay? And you're moving leftward. Are you going away from the origin or closer to the origin? You remember that concept? So I'm basically tying up the concept. So I just made up this number. So let's write a conclusion. Since x of pi over 6 and x dash of pi over 6 have the same signs. At theta equal to pi over 6, the distance of the object. Oh, who remembers what we call x? X is the distance from the y-axis. You guys remember? Okay, at least some of you do. X is the distance. At theta equal to pi over 6, the distance of the curve or the particle from the y-axis is increasing at the rate of monkey radians per second. Ignore the negative sign, yeah? We're doing absolute value. I hope you understand why. Basically, it's like position velocity. You're on the left, moving leftward, so you're going away from the y-axis. Okay, if you just copy it on C, it says the curve r equals sine theta is also shown below. To make it easy on yourself, see if the notation comes back, call it R2. R2 equals sine theta. You can go back and call that guy R1. The function we've been dealing with is R1. Because I'm going to sketch that figure. Can you go back up? Either draw a new figure or just draw another circle with that figure. So you have like that, and then they have a circle like that. I'm going to call this guy R2, and this is R1. Okay? Now here's the question. It says, find the area of the region outside the circle, but inside the weird function. Repeat, it should be outside the circle, but we are inside the weird function. Can you please shade the region we're interested in? Like this is the region I'm interested in. Outside the circle, but inside the weird guy. And then check your answer against the board. Like this is what I need. Okay. All right. This is a calculator problem. Who remembers what we find next? Sorry? The points of intersection. So make a note to yourselves. We're going to find the points of intersection. Should we just set them equal to each other? So we're going to do R1 equals R2, or rather R1 minus R2 should be equal to 0. I'll find the x-intercept of that guy. Now, in case you've forgotten how to plug this into your calculator, I'm speaking, so look at the board, please. Will I just plug in that guy minus that guy, but make sure instead of theta, I type in x. Exactly, you're typing x. I'll write that down for you. X plus cos 2x minus sine x. So you're finding the x-intercept of that guy. Now, assume for a second the intercepts are monkey and donkey. I'm going to label this. So that's monkey and that's donkey. Okay, it's been a while since we did polar functions, at least a couple of months. So I need, okay, I'm going to mislead you. Put your pencils down so you can look at the board. Let's do a sidebar for the formula. Some of you shall have forgotten the formula. So the formula for polar is this. A equals, okay, Mazu, do you remember the formula for polar functions? Area? It's R, they have R in it and a theta. There's a factor outside. What's the factor outside for all of the polar function formulas? No, it is not pi. It's 1/2. Very good. So it's 1/2 integral theta 1 to theta 2 r squared d theta. Is that clear? That's the area formula for polar functions. In general. Okay, now look here, please. I'm going to try to confuse you. So here's what I need. Everybody pay attention. I want some smart fellow to correct me. No, that's not how you look at it. We need the area under the curve and area under the curve. I just made a mistake in how I described it. Because that's not how polar functions work. Mr. Banchan? Thank you. He smartly recognizes, let me speak slowly to emphasize what he said. R is the distance from the origin. So look at the board, please. What we really need is the area from here till the origin minus that guy. So the formula becomes, so write this down, if you have two curves, it becomes 1/2 θ1 to θ2, big brackets, see this comes back, R1 square minus R2 square. It is never R1 minus R2 whole square. Never. Okay, it's not a cross-section problem. Again, it's always areas this way. Feel free to sketch. Like if you have on a sector, it's like that. It's R1 minus R2. Okay, let's set it up. So A equals 1/2, big bracket. Initially, 0 to monkey. Oh, by the way, is it smart to label this is R1, so R1 goes here. And then R2, so this is R2. So I need R1 square minus R2 square, outer minus inner, d theta plus, correct? We have another area here. I already have the 1/2. Lower limit, d, donkey to pi. Is it still R1 square minus R2 square? And then d theta. That is your final answer. Relax, your calculator is handling the hard bit. But the AP will want you to see that expression. The AP will need that expression. Define what R1 is, define what R2 is. Alright. Let's see. If I remember right, nobody in this class figured that out the last time. Some of you, I think San Diego came close and then we went far away. Okay, copy down D, please. Copy down D. Oh, by the way, I'm just letting you know, that question was there on your chapter test. That question was there. Not for that problem, but for a similar problem. What the hell? Already? I may have one more problem to do. Okay, I have two more. This is a short problem, and this is also a short problem. Okay, we're here. Nobody speaks. Who can tell me what the concept is? It says, how fast is the distance between the curves? Let me show you how easy it is. Look at me. If I take some value theta here, because they're giving us pi over 6, right? What's 5 pi over 6 after all? 150 degrees. So 150 is here somewhere. So the question says, how fast is the distance between the curves changing at theta equals 5 pi over 6? So what do we really want? Okay, Ms. Marzu. I can't hear you. And then what of it? Thank you. She correctly says, make a note because somebody had forgotten. The distance between the curves for a polar function. She smartly says, isn't that R1 minus R2? Please understand, it's distance from the origin. So if I want the distance between the curves, it's always from the origin. It says, how fast is it changing? So I'm going to make it easy for myself. Let's call this guy the D function. Or D of theta. Depends on theta. And then, how fast is it changing? Do I just need D dash of theta? Theta equal to... So on the test, I allowed you to use a calculator. Write the D of theta function and then do numerical derivative of R1 minus R. Good to go. Okay, let's do E, please. Copy down E. Okay, Marzu helped us with D. Let's see if one of you can take the ball and run for E. It is not a demanding problem. It says, what is the theta in the first quadrant such that the distance between the curves is largest? So what am I really asking for? Ms. Baba? Thank you. I love you, Baba. So she says absolute maximum. And do I also need the absolute minimum? So, did we already do the hard work in part D? So is that distance function basically R1 minus R2? So I do what now? Sorry? So how do I do it? So what do I do? Thank you. Should I find the critical point? So is that just D dash of theta? Guys, please understand it. Look at me. Do you understand the mustache? If you type this into F1, the mustache F2, d or dx, it will graph it for you. You don't have to do any derivatives by hand. So the critical point is nothing but d dash of theta equal to 0. And assume you get theta equal to monkey and donkey. What do I just do last step? I need to evaluate the function. So I'm just doing d of 0, d of pi over 2, d of monkey. Your calculator is doing all the hard work if you just use common sense. Okay, copy down 7 please. Draw a line. It says in your notebook, if you're lazy, just write that in. Guys, in general, I've said this by email, but for those of you not aware, especially if you're struggling, Ms. Boss even applies to AB class. If you're struggling in this, like man, I'm falling behind. Ms. Marzouk, Ms. Dong, and Ms. Huin tutor for calculus AB and BC. I would recommend get a tutor. They charge a nominal sum, but they'll review everything you need. But if you say, I've forgotten a lot of this, I don't know. The homework is taking 2 hours to do. When I'm timing it for 1 hour, it means your concepts are very weak. Who remembers what the formula? Okay, damn it. Okay, Marzu, what's the length of the curve formula? It's basically the distance formula. So d equals integral from 0 to pi, radical x dash of theta, because the parameter is a theta, not a t, square plus y dash of theta square, d theta. But stop. I need x dash of theta. So what should I find first? X of theta? Ooh, we discussed this 2 minutes ago. What's x of theta? Is that just r cos theta? So r is nothing but e theta cos theta. And therefore, can I find x dash of theta? And then I will square it and I'll plug that in. Similarly, can I find y of theta? Which is r sine theta. Therefore, I can find y dash of theta using product rule. That's e of theta. Okay. And then plug that in. So this comes in multiple choice. They'll say, which of the following is the expression? They don't want you to open it up. So don't do crazy stuff that we did. We did it once or twice, but just write it in. Okay, we're almost done. Copy down A, please. Oh my God, Javidi is not here. Here's the reason. I'm going to do a problem. There is one more small. We're not doing B. And he was absent. This is hilarious. On day 1 or 2, he was absent. I taught a concept. He's again absent when I'm doing a review. That's hilarious. So those of you who are Javidi's friends, is the answer to that question no solution? Does not exist? I'm kidding. Remind him to watch the video, please. Okay, we just discussed it. What's the formula for area of a polar function? A equals 1/2 integral. Read the question. So what's your lower limit? Upper limit. What's the formula here? R squared. Look there. So what is the expression really? Theta to the power of? Do you understand why? So take it to the top, use power rule. Okay, just make a note to yourself. Rewrite theta to the power of -6, then use the power rule. Okay. Again, oh my God, what did I write? That's supposed to be rule. That's supposed to be rule. Now I could correct it. Instead of just calling it out several times, I could just correct it. Okay. What's this, please? Oh my God. Bloody hell. All right. Let's finish the topic with this thing about rose petals. All right. Copy down A. It says area of 4 sine 3 theta. Okay, come on in, guys. Oh my God, what's this crowd? Okay. Okay. Your thing is on my laptop, right in front of my laptop. Okay, stop. Go. Stop. Okay, AB kids. Here it is. Period 3 is at period 2 is at the bottom. Period 5 is at the top. Go to the back.
Okay.
Again, period 2 is at the bottom. Period 5 is on top. Clark, I thought you finished.
No, because remember I have to go back because I messed something up.
Okay, go to the back, please. Guys, I need silence. You guys have to keep quiet. Do you want to come in? come in or stay out. Yeah. Okay. Shh. Now, kids in the back, I need you to keep quiet. All right. Okay, let's wrap this up, please. It says sine 3 theta. Who remembers 3 petals or 6 petals? 3 theta. 3. So it's odd. You have the same number of petals. Next, we're graphing it. The sine function petals. Is it on the axis or above the axis? Again, if you do your homework, these are things you're expected to remember. The AP this is pre-calculus. So keep in mind it's 3 petals. So we'll write A equals 3 times 1/2 integral. And then it's 4 sine 3 theta square d theta, right? R square. My goal is to find the bounds. Is that clear? My goal is to find the bounds. See if this comes back. If you're getting back to the origin, can I set r equal to 0? So 4 sine 3 theta, I'll solve the equation, equal to 0. Can I divide with the 4? Okay, now let's talk about trig. This is from last year. When is the sine function equal to 0? Pi and 0. 0 and pi. So on the right hand side, you have 0 and pi. That's 3 theta. So theta equals 0 and pi over 3. Those are your bounds. Now observe the fact that I have 3 petals, circle that. Therefore, you can draw a circle. That's 3, therefore that's 3 there. Okay, last question of the day. Yes. Oh, test? No, look for a test. Look for a test that's unwritten there. There are plenty of tests. I know there are tests, kids have stapled them. Just look for a test that's, and rip it apart. Make sure the name is on the test, alright? But unwritten. Shh. Alright, last question of the day. Copy down, out inside the circle 5, but outside r equals 5 cos 6 theta. Last problem. Shh. So in simple language, we have the radius of circle 5. Okay. And then you have petals. Okay. Think before you answer. It says 5 cos 6 theta. How many petals? 12. And then for cosine function, are the petals on the axis or above the axis? You have to remember that. Okay. So observe, I'm going to start writing. 12 times 1/2 integral. And then 5. Oh! Stop. Isn't it area of circle minus? How many of you understand what I'm doing? Because I need the leftover region. So A equals, is that just pi r square? It's a circle, pi 5 square. Minus, now 12 times 1/2 integral. I don't know the bounds yet, relax. And then 5 cos 6 theta square. Is that clear? Okay, let's figure out the bounds. As before, can I set that equal to 0? So 2 steps down, I'll have cos 6 theta equal to 0. Now trig kicks in, IM3 trig. When is the cosine function 0? Hint, cosine is x over r, so is that pi over 2 and 3 pi over 2? Let's write that down. So pi over 2 and 3 pi over 2. But that's actually 6 theta. Therefore theta should be pi over 12 and pi over 4. But stop. I'm guiding you, so follow my lead. So that guy is pi over 12. What's this guy? Obviously 0. Now stop. Look at me. Now let me show you how virtually all of you do it, and let me show you how part does it. If you go 0 to pi over 12, isn't that only half a petal? So should you double it? But Mr. Park says, Rama, if that's pi over 12, isn't that just negative pi over 12? By symmetricity. Okay, you're above the axis. So Mr. Park says, that's just negative pi over 12 to positive pi over 12. I don't like to double it because, look at me, here's the reason. Is it possible sometimes you'd forget to double that? So he says, I'm just going to do one petal, negative pi over 12. We're done, thank you. Ms. Dong, you can pause the video. If you're an AD, can you raise your hand please? I'm coming to your desk.